how I'm spending my summer vacation.
You and me both.
Yeah,
this is fun, factoring.
What better way could you have to spend your summer vacation on factoring? You know, factoring is one of those skills that comes up again and again and again, and it's not something that you can just like, oh, I'll just punch it in my calculator. No, it's not so easy.
You're right.
So it's really something that you're going to need to become fairly fluent at. Can I say that?
You can, and I think you did.
Can I say at?
Yes,
All
you
right.
can.
So I'm going to factor this guy. The first thing I do, of course, is I look for a greatest common factor. Is there some number or some variable that goes into each of these guys that I can remove, that I can factor out? I don't think so.
I don't either.
And this to me looks like a quadratic. It's an x squared guy, and I know that x squared guys, if they are factorable, which is not necessarily the case, I can factor them into two binomials.
Very
Is it
nice.
binomial?
You can.
All right, well, I'm saying it. So I'm thinking about like what times what gives me the first term. Of course, that's not too bad. That is x times x, in fact, gives me x squared.
Brilliant.
Now I just need something times something which gives me a negative 18. Well, could be 18 and 1. I mean, I could try that, 18 and 1. Is that going to work? Well, somehow I have to get, after I multiply the first guys, gives me the first term, multiply the last guys, gives me the last term. But this middle term comes from multiplying the outers and the inners and adding them up. So this gives me an 18x and a 1x. I don't think I can get a 7 out of that.
I don't either.
So I think I'm going to need maybe a 9 and a 2. Is that going to work?
That's looking like some
Let's see.
potential.
First term works. Last term gives me an 18. I don't know about the signs yet, but the outers give me a 2. The inners give me a 9x. So from a 9x and a 2x, I can get a 7.
You
Should I
can.
make the 9 negative or the 2 negative? What do you think?
Well, I think you want the 9 positive, because that gives you a positive 9x and a negative 2x, which combine to give you a positive 7x.
So then, really, there's no shortcut here. I just try a few things, and now I multiply. I always check by multiplying it out. X times x is x squared. Then I do the outers. That is a negative 2x plus a 9x gives me a 7x. And the last term is 9 times negative 2 gives me negative 18. And there you have it. It's fully factored.
Fully factored. Well done. Should we factor this quadratic? I think that's a quadratic, right? All right, here we go. Set up our two sets of parentheses. So, what does everybody say to you, Mr. Haas, when they look at this?
You know, I mean, it looks to me like the last term, like I need like some number times some number, which multiplies to give me a 1.
Right.
So I guess the last number would have to be a 1 and a 1.
It has to be a 1 and a 1.
And then they have to add to give me a 3. Isn't that, students always say that. They must learn something about that, right? 1 times 1 is 1, and 1 plus 1 gives me the middle term, which is 3. How come that doesn't work?
Yeah, well, unfortunately, that little trick is something that probably when you were in 8th grade or a freshman, you learned that you always look for numbers that multiply to equal 1 and that add to equal, multiply to equal your last term and add to equal your middle term. Well, that's a little trick that only works if this x squared has a coefficient of 1. As soon as there's a non-1 coefficient, as soon as there's a number in front of your squared term, that little shortcut does not work. And unfortunately, that's a little shortcut that you students have used for years and years and years, and now suddenly that shortcut doesn't work. But basically, it's the same thing. You're looking for things that multiply to equal the first term. You're looking for things that multiply to equal the last term, and then the outer and the inner combine to give you your middle term.
So, and that always works, right?
That always works. That always
Even
works.
even if there's a 1 in the front there. It's
Absolutely,
like
absolutely.
Okay.
Because that's what you're just multiplying. You're
So
doing
why do
double
students
distribution.
learn that rule? I mean,
I
it's
don't
just,
even know.
it would be better if they didn't, I think.
I agree.
You know, all right.
So here we go. What times 1 equals 2x squared? Well, I think 2x and x are my candidates there. We already decided that 1 times 1 are my only reasonable factors that I can use. All right, I want to make sure I get a 3x in there. Well, I have a 2x times 1, that's a 2x. My inner terms, 1 times x, that's a 1x. Are you seeing what I'm seeing?
Oh, I think you can just add them, right? All
2x
positives?
plus 1x equals 3x. So everything works beautifully. I have factored that. When you multiply this together, when you double distribute, you end up with this. Voila.
It's a tough one you made up here for me, Miss
That
Stewart.
is a tough one.
As always, though, you're trying to mess me up. This looks really rough to factor, but I think there's a greatest common factor that I can pull out of all these bad boys here.
Yes,
I think so. As a matter of fact, I think 2x goes in evenly to each of them, so I will pull out a 2x, and that gives me a 5x squared, a negative 7x, and a negative 6. Did that right, Ms. Stewart?
That's looking good.
All right, so now I'm going to factor what's remaining in my parentheses here. I still have that 2x. Don't lose that. You gotta keep that, bring that down. Alrighty, so I need now two numbers which multiply to give me a 5x squared. Well, that's not too bad. That must be a 5x and x. There's no other possibility. And now I need, oh, you made this rough. And now I need two numbers which multiply to give me a 6. Well, I mean, I could just try maybe like 6 and 1. Is that going to work?
Let's
Again,
just try it.
I have to go through this every time. First terms, this 5x times x, 5x squared. Last terms, 6 times, that works. The outers gives me a 5x. The inners gives me a 6x. Well, I can't get a 7 out of that. 5 and 6, I can't add them or subtract them. There's no way to get a 7 out of that, so that's not going to work.
That's not going to
I
work.
can kind of tell that 1 and 6 aren't going to work because the outers give me a 30, the inners give me a 1. There's no way to get a 7 out of that either.
Not at all.
I
What
think
the
I'm going
heck?
to need a 2 times a 3.
So go for other factors of 6.
2 and 3, that gives me a 15 and a 2. That's still not going to work.
Oh my goodness.
Maybe I can do a 2 and I just did that already.
You just did
I
that.
did that twice, all right. I can do maybe a 3 and a 2.
Let's try that. Yeah.
Again, the first terms work, the lasts work. Then I go with the middle term comes from the outers. What's that?
That would be
10.
10x.
Thank you, 10x.
The innards give you 3x.
3x. Oh, I can get
Ooh.
a 7 out of that.
10x and 3x.
As a matter of fact, let's see, 10 minus 3, but I have a negative 7. So which one do I want to make negative?
Well, you want your 10x to be negative, so I
Okay.
guess that means that 2 needs to have a subtraction.
And there you go. I think that works. So that gives me a negative 10x plus a 3x gives me a negative 7x. So I'm all set.
Beautiful. You're fully factored.
So, Ms. Stewart, you can see I changed the directions just slightly. A little tricky here. I said factor and solve. Now, I'm making it an equation. It used to be just an expression. I'm pretending that I already set the thing to 0. Some kind of
Beautiful.
equation now. So in other words, I want to know what x values make this 0. Now, I mean, I guess you could try to solve it in this form, but it's going to be kind of rough.
Right.
That's why we factor, isn't it?
Yes, it is.
Because there's no way, really, reasonably, to get like, well, x by itself, and now what do I mean, I can't really, the only thing you can really do is factor it. And you know, the clue here is that if my first term, if my biggest term has a cube, I will have up to 3 solutions for this problem.
In fact, you will definitely have 3 solutions. They might not
Might
all
not
be
all be
real, but yeah.
Right. Up to 3 real solutions.
Exactly.
I apologize for
Just
those
being
of
a
you out
little
there.
math nerd moment.
So I have factored it fully, and as a matter of fact, every place where I have an x is one of my solutions, potentially. So I'm going to set each one to 0. Now, sometimes I think the students don't really know why we're setting each one to 0. Does that even...
Yeah, I think, again, a lot of times people just do a shortcut.
They do, but really what I'm saying is, hey, if I have 3 things, some guy times some guy times some guy equals 0, what must be true? If something times something equals 0, the only way that can happen...
Is if one of them equals 0.
That's right. That's why we set it to 0 in factor. So
Right.
if this guy equals 0, well, if I divide both sides by 2, I have x equals 0.
There's one of your
That is my
solutions.
solution. If I solve this little linear equation, I have 5x equals negative 3. x equals -3/5. That's another solution.
Beautiful.
And I'm just going to add 2 to both sides. I have x equals 2, and that is my third solution. And actually, I could take these x values and put them back into my original equation one at a time. If I stuck in a 0 for all these x's, I'd get a 0. If I stuck in a -3/5 for all these x's, that would be a little rough. I would get a 0, and if I stuck in a 2 for all these x's, I would also get a 0.
So you found the 3 zeros. If you were graphing this thing, that's where the function would cross the x-axis, right?
It is. It's all kind of comes
It
together.
all comes together. I love math.
with the Sultans, with the Sultans of Swing.